All right, welcome back, everybody. Sorry for the few minute late start. Trying to convince people math isn't the devil it isn't as easy as it looks.
Yeah.
We're on 11, aren't we? Yeah. Like today, 11, we are prepping for 10.3 and 10.4. 10.3 is on the quadratic formula, which we derived at the end of the last class on Tuesday. We derived it from scratch. And 10.4 is on equations that look quadratic or can become quadratic. Can be solved quadratic as quadratics. So 10.3. This one is a lot of just, what is everything? Just plug the shit in. So quadratic formula, let's just write down, let's get it on paper. Starting with ax squared plus bx plus c equals 0. Every solution to this equation meets the formula x equals negative b plus or minus the square root of b squared minus 4ac over 2a.
The same thing.
What?
That's the same thing. Those two equations are the same.
Effectively, yes. They literally are. We took this one and solved it and got this one. So this is derived from this, but this gives you everything in terms of x. So like a, b, and c are numbers. X is our only variable. With a, b, and c as numbers, we can just plug them in to find x. Grab some examples from over here. All right, so first example we'll do. We're gonna do x squared minus 6x minus 2 equals 0. So what does a equal, what does b equal, and what does c equal here?
A is 1, B is -6, and C is -2.
Does everyone see that? Even though we don't see the 1, there is a 1 here. It's the hidden invisible one. So that's what we're gonna plug in. You might find it better, it's a little more work, but go ahead and set it up with parentheses for every letter. Oh, I didn't want to write the letter A, just leaving it blank. Then we're gonna go through and plug in what the letters are.
Why is there a negative at the very beginning?
That is part of the formula.
Oh, you're right. Okay, just kidding.
Just kidding. Okay, you got me. I got tricked.
Oh, for it.
Me go for it, you go for it.
I said you fell for it.
Oh, I fell for it. All right, so where are the A's? The A, there's an A right here. And there's an A right there, so we're gonna plug in the ones there. The B's, there's a B right there. And there's a B here. And finally, C is over here. Now it's just taking your time, don't rush it. Now, what is -6 equal? It's +6. And then we've got -6 squared. What is -6 squared equal? Plus +36. Anything squared is always positive, so you don't even need to worry about the negative on the B squared. It is important everywhere else. We're gonna take -4 and multiply it by 1, which doesn't do anything into it. And then -4 times -2 is +8, so we got +8. On bottom, we've got 2. So we'll continue. We've got 6 plus or minus. We add 36 and 8 together, we have 44 over 2. Forty-four is 4 times 11. And so like square root of 44 is like square root of 4 times square root of 11. So this turns into 2 root 11. So we got 6 plus or minus 2 square root of 11 over 2. Why are you shaking your head left and right?
Well, I'm trying to figure it out because like I understand that you wanna like square it. So I'm just telling myself that when you square it, it's only gonna be that one number that's squared, that's gonna stay out of the.
Yeah, yeah, it's the only one that has a square sign on it. So let's finish this one. I'll give you a little like story
Okay,
that you might like that will help you memorize the formula.
okay,
It's cheesy, but I heard it and I liked it. I only heard it once and I remembered it because it was that bad.
okay.
Alright, so. This is literally, we can break it up. This is 6 over 2 plus or minus 2 over 2 root 11. And that simplifies to 3 plus or minus the square root of 11. So we have two answers, x equals 3 plus square root of 11. Or x equals 3 minus square root of 11.
Why isn't the root 11 divided by 2 as well?
Because it cancels out the 2 here. I could have left it as 2 root 11 over 2. And like when you have shit multiply together, like if I did 2 times 3 over 2.
Which is.
2's cancel and we just have the 3.
Okay.
That makes sense?
Yeah.
So square root 11 isn't any different. Alright, so we have two numbers. These are the exact solutions. These are what you want to have. These are not what you'll use if you're actually using them in a problem. Like to do an application, because I don't know what 3 plus square root of 11 is. I can get pretty close. I know square root of 9 is 3. And I know square root of 4 is 6, or 16 is 4. So maybe square root of 11 is like 3.3 or some shit. I don't know. Something like that. I can get close without a calculator, right? With an exact answer, you get an exact one or an approximate one with a calculator. We call it an approximate one because the calculator doesn't show all the decimal places. If it does show all the decimal places, bam, you're done. But if it does, you probably didn't need this. It probably stopped being a radical. So, Jackie Stortle. I'm gonna write down the equation real quick so that you can see where I'm going with this. And I'm gonna do the story again in the main class. There was a negative boy. He was such a square. He was undecided. About going to this radical party. He ended up missing 4 awesome chicks. The party end was over at 2 a.m. Did it work?
That'll work.
This is our negative boy.
Yep.
He was a square. It was a radical party. He missed 4 awesome chicks. Missing is like minus 4 AC. Over 2A.
Would you say that he was undecided, it could be plus or minus?
Yeah, the undecided is the plus or minus. Sorry, I missed noting that one. Yeah, it's called the quadratic formula. And as much as you think you emailed me, I don't see an email from you. I wonder if it's in. I wonder why. Oh,
Got it?
well, no, I don't, but we'll do it at break.
Okay.
I just happened to look up and realize that it wasn't there.
What was I gonna say? I feel like I've seen the quadratic formula be applied in statistics, but I can't really remember why, like, is there a reason? Or like, do you know what it was used for? No, you may not. Taking statistics for a while or taught it, but like, I'm just trying to think of what we used it for.
So, least squares regression has a square in it. You might have used it there to get, but I can't see why. I can't picture any.
It was probably like a formula that looked exactly the same, but like.
It was probably one that looked similar, yeah. Oh, there's lots that look similar.
Oh, yeah,
With the square root, yeah, there's lots.
like fucking plus or minus.
Yeah. That shows up a lot.
Oh, yeah.
Let's see, let's do another one like that. Back this time, we're gonna let you do it. 3u squared minus u plus 6 equals 0. So I'll write down the formula. It's changed a little bit because we're using u now. It's not an x. But the right side is still the same. Go ahead and work that out, and then we'll do it together in a couple of minutes.
You just want us to put it in like the quadratic formula form.
Yeah, put it in the quadratic formula, simplify it as much as you can, get a nice, as clean as you can answer. I don't know if this has a clean answer. I suspect it doesn't. Well, it might. There might be whole number answers. No. No, there's not. Here, Berto. So relying on calculators.
I don't know my 12s very well.
What?
I don't know my 12s very well.
I'm just trying to figure out. If there's anything I could turn root 71.
Is that what it ended up being, 71?
Yeah.
71, I believe, is prime.
That's what it's.
Is that what you call it? If you can't do anything to the root?
You just leave it out, you can't simplify it anymore. So it sounds like a lot of you got the same thing, how close are you, Sarah? Good, okay. So what's A, B, and C real quick?
A is 3, B -1, C 6.
I just started writing A is 1 for no fucking reason, and I'm like, why did I write this? Alright, so we got U equals. We got negative B, which is -1. Plus or minus the square root of -1 squared minus 4 times 3 times 6. All over 2 times 3. So we got, that's a +1 right there, right? And then I've got 1 minus 12 times 6 is 72 over 6. 1 plus or minus square root of -71 over 6. So the only thing we can really do with that is pull out an I. And make that positive 71.
You have to.
Yeah, what is?
You should. It's not correct if you don't, it's not complete, it's not
Is it
finished.
because it's a negative square?
It's because it's a negative inside the square root.
Okay. And you only have to do that if it's a negative in the square root.
Yes, because square root of -1 equals I. And so like, it's effectively writing this as -1 and 71. And then this turns into an I. So as a reminder, that is 2 different answers. You can leave them as 1 break fraction if you want. Or you can split it up where you do like 1/6 minus I root 71 over 6. That's the other U.
You can't just leave it as 1 plus or minus I root 71 over 6.
You can, if the computer will take it. It's just, I'm making sure that everybody knows it's 2 answers.
Yeah.
It's easy to forget that this is 2 answers, because it looks like 1. But the plus or minus really means 2 different answers.
So you would take the plus or minus, say it was on test.
Yeah. Unless I ask for approximate values, and then you kind of have to break it up. But that one doesn't really help on an imaginary one. So last problem, we ended up with real numbers. They weren't friendly numbers, but they were real numbers. There's no I. This one, we ended up with complex numbers. Is there a pattern to it? Yes, there is. We'll be talking about that in Math 35 in a half hour or so. I wanted to get some more practice in with some tougher quadratics. The 10.4 stuff is the good stuff. So stuff from 10.4. Equations that look quadratic. Or can look quadratic. My first example is going to be x to the fourth minus 5x squared plus 4 equals 0. And you're like, hold the fucking fort. There's an exponent with a 4. That's a big, that is not a square, that's a 4. Right? But x to the fourth is x squared squared. Minus 5, we have an x squared here. Plus 4 equals 0. If I am comparing this to AU squared plus BU plus C equals 0, which is quadratic. That's quadratic. Quadratic means it's got a, it's a square max. How do these two compare? How can I make the connection there?
The user x squares.
Yeah, if u equals x squared. Then x squared squared is u squared. And this becomes u squared minus 5u plus 4 equals 0. So the trick. If it's an even exponent on the big one. On the big exponent, I should say, bigger exponent. Let's say that, bigger exponent. And that is twice the smaller exponent. We can go quadratic. Making u equal the variable with the smaller exponent. The smaller exponent is the 2. The 4 is twice as big as the 2, which means we can make it quadratic. So we make u the smaller variable, or the variable with the smaller exponent, the x squared, that makes the other one the square. Does that kind of help? I don't know, is what's supposed to be blue. There's blue, green, red, and black going on up here. The only blue line on the screen is this one, Heriberto. No. Okay, let's raise the brightness. That help? Okay. So let's go back to doing this one. So I've got u squared minus 5u plus 4. We can solve this using any technique we'd like. You can use quadratic formula if you'd like. This does factor though. What are the factors here?
One and four.
1 and 4. So I got a U, a 1, and a 4. And to get a negative here, one of them's gotta be negative. And to get a positive here, they both have to be negative. So this becomes u minus 1 equals 0, or u minus 4 equals 0. We get u equals 1 or 4. But we didn't start with u, we don't end with u. So we gotta take this and plug x squared back in. So u equals 1 becomes x squared equals 1. And u equals 4 becomes x squared equals 4. We do the whole extracting roots, we get square root of plus or minus square root of 1, which is just 1. And here we'll do the plus or minus square root of 4, and we get x equals plus or minus 2. And we should probably check in the original equation. It kind of doesn't matter whether I stick in 1 or negative 1. The squaring is gonna. That's a 4. The squaring is gonna get rid of those signs, right? So I can do 2 at once, that's convenient. This isn't always possible. This becomes 1 minus 5 plus 4. Does that equal 0? Yes, it does. So x equals positive 1 or negative 1, both work. Now we'll check 2. Plus or minus 2 to the 4th power minus 5 times plus or minus 2 squared plus 4 equals 0. 2 squared is 4. That's a 4 right there. So this ends up being 4 squared, which is 16. (16 minus 20 plus 4 does equal 0. So plus or minus 2 works also. Take it, put it on your fridge. Did you put the stuff on the fridge from last week? Or Tuesday? No, we talked about it, how it was fridge worthy.
What was February?
What wasn't fridge worthy?
Oh, the actual map, okay.
Like, what the fuck?
I don't know.
It's like I'm speaking Greek up here. It's been 2 days.
It's been a long week.
You guys wanna try one?
Like this?
Yeah. What'd you think I was gonna fucking say?
I don't know, I was hoping for like something delicious.
This is the easiest version of these. I will give you one with x to the 4th. This is the easiest version. You guys try. Make sure everybody's on the same page. What is U here?
X squared.
And so what does this equation turn into?
Or U squared minus U.
Alright, good. Right. That's where you stopped?
Yeah, because I'm trying to figure out what multiplies by 5 and comes to so.
So if you find yourself spending more than a minute as you're trying to factor. No, that doesn't mean it doesn't factor, it means you haven't found it yet. You can go to the quadratic formula. Or you do a table with the factoring approach and you get it much quicker. So you take the first number and the last number, you multiply them together. You need two numbers that multiply to that, which is the -20, but add to the middle number, which is the -1. Be systematic about it. They multiply to be a negative, so one of them's negative, one of them's positive. They add to a negative number, so the bigger number is negative. So I just started off with the most obvious factor, which is 21, and I made the bigger one negative. That didn't work, that gave me -19. The next one down, next number I can try is a 2. 2 times 10 is 20. This adds up to -8, didn't work. Next number down is 3. 3 doesn't divide into 20, so next number down is 4. 4 divides into 20 is -5, and I quickly found it. You might have to do it by grouping because it may not be obvious. The 4 is probably throwing you off. That -u becomes -5u plus 4u. And if we group. Now, the advantage of the quadratic formula. It takes you straight to the fucking answer. There's none of this. There's a lot of shit going on here, right? So if you do the quadratic formula. After you simplify. You should get u equals -1 or u equals 5/4.
When I do the quadratic formula. Or when I do this.
Yeah, the quadratic formula should give you these answers. So, which means that radical sign is gonna simplify, it's gonna turn into a whole number. I would go through and do the radical or the quadratic formula on that one though. If you didn't recognize the factoring, because this is the quadratic formula day, it's good to get that practice in. And we're not done with the problem anyway, so I'll stop and let you guys work. Fucking spiders in here. They're so loud. And fragrant. Ah. Don't come up here. You've been warned. Goddamn, I might need to get up and move, that's bad. Oh my god, it's just diffuse or something, what the fuck? Spread. It's doing the quadratic formula approach. It's not fast work without practice, what did I do, James?
Well, no, those aren't the same as the factored version.
-1 or 5/4. The factor version you have to solve first and it changes the signs of everything. A lot of people rush through this and get the wrong sign. They'll say this is +1 and they'll say this is -5/4.
Don't you have to add something like square root?
Yeah, we're not done.
Okay.
Yeah, we're definitely not done. Good catch. I was just showing that it doesn't matter which way you did it, if you factored it or did quadratic formula, you're gonna get the same U. A couple of people are still working, so I'll let you finish it up. All right. So we have U equals -1 and U equals 5/4. We will substitute x squared back in. And when we do the square root. x equals plus or minus square root of -1 is I. This is x equals plus or minus. Can't do anything with the 5, but the square root of 4 is 2. So let's check. So checking I or negative I. With the even exponents on both of them, they're gonna end up being the same. So I is square root of -1. I squared is -1. And I to the 4th power is I squared squared. Which is this squared, which is +1. So that ends up being a 4. Minus. This is I squared, which is -1. Minus 5 equals 0. And we're checking it, so I'm gonna put question marks to show that we're checking it. 4 plus 1 minus 5 does equal 0. So that's a valid bingo. Yeah, that I shit keeps coming back, the radicals, all that stuff keeps coming back. That's why we tried to review it, and I know it was felt like fast. You guys got it good. Calculus students in a year are just fucked. They're just gonna get fucked. They're gonna come in, their algebra is gonna be weak, and they're not gonna have any algebra class to fucking take with it. Alright, what about the other one? So we got plus or minus square root of 5 over 2. We're plugging that in. That to the 4th power. Minus that to the 2nd power. Minus 5. Does that equal 0? Now this is gonna be uglier because it's got fractions. Square root of 5 squared is 5. 2 squared is 4. So that becomes 5/4. This one is effectively 5/4 times 5/4. Because remember, we wrote this as this squared. So that's 5/4 times 5/4 right there. And I didn't calculate it yet. Because it's gonna make it a bitch, I think. Oh, look. I'm gonna pause for a second. Is this clear? So we had square root of 5 over 2 times square root of 5 over 2. We get square root of 5 squared is 5 over 4. If we do that to the 4th power, I want to make sure everybody's on the same page. That's what to the 4th power means. But this is a 5/4. And this is a 5/4.
Okay, so which row?
Right? So this is the x to the 4th part right here. When I plug in square root of 5 over 2. And I could multiply them together and get 25 over 16. But that's not gonna be as helpful actually as leaving it in the substep. Is everyone better with that? Jackie. You've got those vacant eyes.
I don't even know what the hell is that. I don't know where the I came from.
The I is the square root of -1.
I think I didn't plug it in, so I'm just kind of watching.
Alright, I is separate, we did that up there, let's go back to, let's finish this one, we'll go back to I. Are you okay with the 5/4 here, the square root of 5/2?
No, because again, I didn't go back and plug in, I didn't go back to X.
Oh, you didn't go back to
I
X,
didn't do, yeah, so I'm just following along.
but is the follow along fine?
Yeah,
Okay,
yeah, I understand what's happening.
okay. So this is like 4/1. This 4 can cancel that 4. And I can make this a little bit easier, that's 25 now over 4. Minus 5/4 minus 5. Does that equal 0? We got fractions, we can do one or two things, we can say fuck fractions. Or we can put them together. Putting them together actually kind of makes this a little easy. Cause that's 20/4. Which is 5. 5 minus 5 does equal 0. So. Granted, plugging this in with a calculator would be a lot quicker. And you could find out what square root of 5/2 is. It's about 1 point something. I don't know exactly what it is, it's 1 point, like maybe 1.1. But whatever it is, you could have it in there, you could do it to the 4th power times 4, you could plug it in and go quicker. This is like working with all the fractions. But both answers checked, so both answers were good. I mean, this, I guess I could. I'll pause it. I mean, we can work between classes, if you wanna walk for a second, you can, take a break. But just as a reminder, I is square root of -1. If I square both sides. If you square root of -1, the square root goes away. I cubed. Is those two multiplied together. Because I cubed is. I squared times I. So I cubed would be negative square root of -1 or negative I. And I to the 4th power is I squared times I squared. So that's -1 squared, which is 1. Just gotta remember that cycle for i's. They're either plus or minus 1 or plus or minus I. And that just means going through this slowly when you plug it in.
Wait, what's I cubed?
Negative I,
It's negative I.
yeah.